Hello, my name is Adam Bean and welcome to Live Coding No Ceremony Microservices. What I would like to do is to code a little bit microservices with nothing but standards and see how it actually feels like if you would just focus on the standards without using any external libraries. Okay, let's start with the content. So thank you for the invitation to the Java with the Best conference and start with the topics. Okay. So I'm working as a freelancer or consultant, and I really like Java, so really enjoying it. Also, I have to say the last time I do lots of Java-y backend stuff, I would say 60–70% of my time, and the remaining time I spend with web standards in the front end. Okay, so I've written a blog, it's more or less a notepad. There's a bunch of online courses, and by the way, there's one course which might be relevant today is Java-y Microservices. So if you like the content and the lightweight nature of microservices, take a look at this course. And so there's the first Monday of the month, I try to answer technical questions via live streaming via exactly this channel. And from time to time, I publish a podcast. Okay. So what's the idea? Learn once, never migrate. So this is the idea with web standards as well as backend Java technology. So if you focus on standards, there's less to do because they do not change that often. Okay. So, and this are basically the slides. And if you like, come to Munich. Next winter, there will be one microservices workshop as well. So this is the very last slide. So thank you for watching and see you next time. Bye. No, just kidding. So let's start with the content. And what I would like to do is to create a microservice from scratch. And how to do that? So I will use Maven, and I use Maven archetype, so you can use it from command line, from the IDE. I do it right now from the IDE. This is the Apache NetBeans, which happened to be NetBeans, but was open source, and now it's Apache NetBeans. And I would like to use the Java 8 archetype, and the current version is 0.0.2. This is the current version. And the name of the microservice is, what to call it, what we could do today, workshop. So we have a workshop. Let's create a workshop. Workshops. Okay. Now it's going to pull the project definition via the internet. The performance of this depends on the performance of the Sonatype Central. So sometimes it's lightning fast and sometimes terrible slow. And yeah, let's take a look at the Maven definition. I get often questioned to know whether I like Maven or Gradle. And for Java, I prefer Maven. Why? Because it's very lean. What we usually get in my projects is some test dependencies. And in this particular case, I would like to use Java EE 8. In Java 7, you would have the 7 and 6 the 6, but 8 is good enough. And what happened behind the scenes? So I created a bin.xml deployment descriptor or configuration file, and I like the bin discovery mode all, which means dependency injection works everywhere. And what also happened, I have an endpoint called ping resource, and with enjoy Java 8, and the microservice is configured to expose resources. So this is the entry URI. So per definition or per convention in Java, the URI would be workshop/resources/ping. So with a little bit of luck, if I would run it, and I would like to run it on Payara 5, which is the supported version of Glassfish 5, and Glassfish 5 is the reference implementation of Java EE 8. So Payara 5 you can use in production, or Whitefly 11 or 12, or Tommy or Open Liberty. There are lots of application servers. And now let's just try to run it locally. So I will just click the button OK, and then run it. So run it. And what happens right now, the database boots and the Payara also boots locally. So now it starts. And I had some Cassandra stuff installed, which is not relevant for today. So I will just deinstall that. Yeah, we don't need any Cassandras today. We just need the... So it took a while, but we deployed behind the scenes 4 different applications. So right now we have just the workshops. Okay, now what does it mean? That with resources pings, pink resources and not pinks rather than pink, we see enjoy Java EE, so it seems to work. So we have our NetBeans, and here we have enjoy Java EE. So, and if I would add something more dynamic, we should redeploy, and we should see immediately the difference. Okay, this is the simplest possible Java EE 8 application. The question is, what is a microservice? So microservice means we have just one application per application server, so one war per application server, and runs in a process. So we have one JVM, one application server, one war. So we don't need clustering, multi-domains, nothing. We use application server as a operating system, if you will, and this should run in Docker. So we started outside. Now let's try to make it run in Docker. So what is to do? So what I usually do in production, I'm using my own open source project called Dockerizing, and you don't have to use, of course, this open source project. Rather than the idea is more important than the project. And what's the idea behind? For instance, I have here Java 8 Docker file or Java 10 Docker file, and let's go to the Java 8. And what you can see here, that this Docker file is based on CentOS 7. And I need an unzip and Java 1.8 OpenJDK, and then I set the Java home. So this is the uppermost image, and this image only change, or there has to be rebuilt in case we get new release of Java. So what we also have, let's switch to Whitefly, for instance. So in the Whitefly, it inherits from Airhex Java, and this is Whitefly 11, then downloads Whitefly, and then sets up the Whitefly, so it runs on different user, so it can be run on OpenShift, for instance, in the cloud, and then it exposes the port 8080. So what does it mean? We have 2 layers. The first layer is the Java layer, then we have a Whitefly layer, and let's say we would like to make it run it on Whitefly. So we started in Payara, but let's try it on Whitefly right now in Docker. So how to do that? So what was created here is a simple Docker file, as you can see, from Airhex Glassfish, but let's try it with Whitefly. Wildfly. And because we have Maven, I know that the name of the war of the project is name of the war. So I will copy the target workshops war into deployment dir, and the deployment dir is the deployment folder where Tommy, Whitefly, Open Liberty, or Payara are scanning the wars. So let's try to build that. So I will switch to the terminal, and we should have workshops here. And how to make it run? So I have a script was also created, but let's do it from scratch. Maven clean install. Clean install or package is enough actually. And Docker build, and we can use a tag name, Airhex / workshops. Hopefully it's not used yet. And what happens right now, it will build the binary image. And it's done. So it's very fast. Why that? Because the only thing which changed, so there was the full Maven build plus the full Docker build. So first, good news, if you use Java EE-based microservices, the build is lightning fast, which is very good for productivity, because we usually have a CI, continuous integration, continuous delivery pipeline, and waiting for too long is not that ideal for productivity. So we have that, and I would like to run it in Docker. So the name of the image is Airhex Workshops, and to make it run, Docker run in background, -d is detach mode, so it means in background, and I would like to expose the internal port 8080 to 8082. And I would like to give it a name, workshops, and use this image name. So it's done. So it boots. And let's take a look. So it runs, and we can also take a look at the logs. And as you can see, it's deployed. And now let's see. So we can make it run on 8082, and it also works. So and to show you that it's actually whitefly, I can actually I think it's cached, because it should be a whitefly. So this is the glassfish. This is the Payara. And this should be whitefly, but it looks like glassfish server, which is a bit strange. But it is glassfish 5. So what's the problem here? Docker file whitefly. I didn't save that. The problem is, so we ran it accidentally on glassfish because I forgot to save it, which is true. So now you saw it running on Payara, glassfish 5, and now try it again with whitefly. So I would just rebuild that. So build it again. So now it should take the whitefly server, and before I run it, I will have to kill it. Workshops. Get killed. Get killed is German. Killed. So, and now run it again. Where is the run script here? Workshops, and hopefully now it's going to be whitefly. And it is whitefly. So it looks good. Whitefly looks better. And it was workshops, resources, pink. And this is the response from whitefly. So now we deployed the application twice, or 3 times actually, using Docker and Maven. So this is the worst possible experience because we don't have any Kubernetes, nothing, just plain Docker with CLI and plain Maven without any additional tools or specific, IDE support. Okay, nice. So the next question is, I get a lot. Okay, this sounds interesting, but how you configure such application in cloud native way? And if you run in Docker, there's only way to configure such a thing, and this is via environment entries, because in cloud, usually Kubernetes injects the environment entries to your application. So let's try to show how it works. And I would like to add configuration dot boundary, a configurator. Let's call it configurator, and the configurator exposes the configuration as string, expose, and I would like to use the injection point IP, and produces, and this should be this produces. And what I can do, I can say, okay, nice, I would like to first check what's the name of the what's the key, member get name. So I ask about the member and the name, and then I can return system get env get or default key. It means I would like to get the key from the environment entries, and if not available, I would like to use my system property. And the system property is very helpful for local development because it is harder to change the environment entries. So what I usually use, I use system properties on my local machine, and I use the same key. And if not available, I can say here, not set, or I could throw an exception, of course. So now I have a generic configurator. And what I could do right now, I could, for instance, inject a string hello message, or just hello, and and then just add this hello. Okay, we will have to build it again. Yeah, we have to build it again because we changed the source or bytecode. and then kill it again and run it. Switch here and see what we get. Not set. So good news first, something got ejected, so this is not bad. And what I will have to do is to set the hello. So how to do that? We will remove the workshops and run it again, this time with -e. And I can say -e hello equals hey Duke. And -e is environment. So now it's set. And I can switch to here. Hey Duke. So this is how you usually would configure Java EE applications in cloud native way. And what you of course can do, you can specify here n file. This is --n file. And you can specify now key value pairs, which are then stage dependent. So this is a built-in Docker functionality. On OpenShift or in cloud is even easier, because then you have config maps or deployment configs or build configs. I just quickly switch to Twitter, whether there are questions, or in chat, also no questions. So this was how to configure applications. And now let's create another microservice, because one microservice is a little bit boring. So the next question is how they can communicate, or how to make them communicate with each other. So then create another microservice, and with the 0.2 version, and I would like to call it trainers. And takes a while. Okay, so we have the trainers now. This is the same structure, so no surprises. And we also have the ping service. And now what I would like to do is to expose a business object. Or business object, a resource called trainers resource, and we would like to get from the workshop the trainers. So this is the idea here. Trainers, and just create a get call which returns the trainers. And the trainer should be the Duke and Fluke. No idea. So 2 trainers. And this should be good enough. So we can change again. I would like to, we can keep it this way. So it could be Glassfish v5, why not? So we will run the trainers on Glassfish v5. So let's try that. I would switch to trainers and Maven clean package. And afterwards, I would like to build with airhex trainers dot. Now it should build that and make it run with Glassfish v5. Docker run -d -p, and the port number, just go with 8084, 8080, name trainers, airhex trainers. Okay, looks good. Docker ps. So now we have workshops and trainers running, both. And let's see what happens when I ask here 8084 resources, sorry, not trainers resources, and I guess trainers. So yeah, 2 times trainers was a little bit boring, but this is how it is. So, and now let's say I would like to call this URI from the workshops microservice. So I have here the workshops microservice, and I would like to call here my workshops. I will create a workshops resource. Workshops resource with path workshops, and return the workshops, and this is going to call. So this should be workshops boundary. Just refactor that quickly, and then workshops catalog, and this would be stateless, and then we could return the workshops here. And which workshops we have? Of course, we have web standards, microservices, and lean and fast. Okay, so we have this, and the workshops resource, we can just inject this workshop catalog and say here this workshop catalog, ask for workshops. And then what I would like to do is to add a class which fetches the trainers. So, and this is going to be a control, and this would be, how to call it, trainers. What catalog? Trainer catalog is a little bit strange name. Let's call it trainer store. And the trainer store, what it does, it has a method called init post construct, and it should return. And what we would like to do is here, actually, we would like to access this URI here, which is a little bit complicated. I'll show you in a second why. But return fake. So we have trainers, we have init, and we could actually in here say this workshops. This would be return workshops. And what we also would like to have is inject the trainers store, and here add the trainers, this store dot trainers. Okay, workshops and trainers. And so let's try that. So whether it works. So what we should do, we should redeploy the workshops, and we save that, which is already good news. And I will just switch to different console and say here docker build workshops. It's build, remove workshops, run workshops. Perfect. So with a little bit of luck, we should have another endpoint here in 8082 workshops resources pink. So this works. Workshops resources workshops. We see here lean and fast and fake. So obviously it's just fake, but at least we integrated the class. Okay, now the problem is with the localhost. So we have two independent JVMs, two independent Docker containers, even Linux distributions could be, and you know how to get the name. And the good news is, because of Docker or clouds, the DNS happens behind the scenes, so we don't have to bother with the IP address. Instead, what I can do, I can rely on the container name. So instead of doing this, I can say what I would like to use is the container name. What's the container name? Docker PS. So just clean it, Docker PS, Docker PS. and the container name is trainers. So I would like to use just the trainers here as an URI. And what's the port? The port is the expose port, regardless what the actual name was. So I would like to use this. So this is my URI, and then client builder, new client, just do that. This client. So we have the client, and then this client target, use the URI, and I would like to return this target, call it trainers target, and then so we have the trainers target, and here I could just say this trainers target request get, and I would like to get this as string. So what happens now, we are accessing the other server with the name trainers 8080, and it will work. The problem is I will have to set up a Docker network for that. So sounds complicated, but is actually fairly simple. So how to do that? I would like to create a Docker network create, and call it workshops. And now I can say Docker network connect workshops, and this was a stupid name, workshops, because this is a microservice name and the workshops name, and Docker network inspect workshops. As you can see, workshops are now part of the network, and I can repeat that with trainers. So now Docker network inspect workshops, and we see that trainers and workshops are both inside the network with the name workshops. Okay, it could already work. So let's see if we just try that. It won't work. Why not? Because we changed the source code here. So I will have to rebuild the workshops microservice. So there are no miracles, even no miracles with Java EE. So Maven clean package, just do that. So now we rebuild this thing and then remove workshops, and now run workshops. But what I could do now right away, I could tell the container to run this microservice within the workshops network. So Docker PS, we have both, and go to the browser here. It's a pity. So it should be not fast and fake rather than something else. But let's see. I'll just go to the curl and fast fake. Oh, it's not saved again. Workshops clean and build. Workshops removed, and workshop started with hey Duke workshops ahex workshops. Perfect. Okay, now it waits for the localhost, and we have fast Duke and Fluke. So this Duke and Fluke comes from the other microservice. So we made two microservices communicate with each other. Again, just with plain Docker without any additional tools or frameworks. So let's see what happens here in Twitter. Nothing. No questions here. No questions here, which is good. so we can move faster. Okay. Now, it is not very robust, the way of communication. Why not? Because there are no timeouts, there are no bulkheads in place. So bulkheads means if this server is too slow, what could happen is that it will slow down my servers and eventually kill my service. So in order to prevent that, I would like to introduce timeouts first. So instead of doing this, I would rather go with the new builder and say connection timeout, and the connection timeout should be 1 second. 1 second. And then read timeout, also 1 second. And then I can build the client. Now, if the other server is not available, I get an error. Now the question is, what happens in error case? So if this method is not successful, we should do something about that. And what we could do is to implement so-called circuit breaker. So and in Java EE we have already a built-in circuit breaker. So let's try that. New Java class, and let's call it, or just put it here, workshops. We are in the package control, so I will pull the circuit breaker here. And the circuit breaker translated to German is Sicherung, which is funny name, so I will call it Sicherung, just for fun. Why not? So we have the Sicherung pattern. It would never take off with the name. So object and call it guard invocation context IC and throws exception and return IC.proceed, and this will just invoke the method around invoke. But what I can do as well, I can introduce a atomic integer should be enough. Arrow counter new atomic integer. Now, what I can do now, I can just say, okay, in case an error happens, catch error in case the error happens, I will for sure increment the counter and then rethrow the exception, and yeah, rethrow the exception. Then I can ask, in case the error counter get is larger than 2, return null. And now the circuit is open, so the actual method is not going to be called. So now let's install the Sicherung. So in order to be successful with that, this should be a singleton. Why? Because there is this one instance of the backend microservice, so it's easier or more natural to represent that as a singleton. If you don't like singletons, we could just make this static. So there are both possibilities. And in case it's a singleton, I can make it a little bit more concurrent. So okay, please do not log anything. And then I would like to install my Sicherung here. So interceptors, and this is the old interceptors. Whatever I show you right now is actually ancient. So there's nothing new here. Sicherung class. Okay, so we have the Sicherung, and now the trainer's method is guarded. So on error, the error count is increased, and I will just say Sicherung is open, and here error happened, and plus error counter get. So we have this, and should look good. So, and let's test that. And to invoke. And by the way, system out print line can become the next best practice, because frameworks like OpenShift or other cloud native frameworks are able to gather the logs from the system out print line. So this could be one way of writing log files. Of course, the problem a little bit is that if we look at the implementation, it's synchronized. So the concurrent behavior really depends on the performance of your logging framework. So we have that. So let's see what happens. So let's rebuild the workshops again. So kill the workshops, build the workshops, and run the workshops. And run them. And take a look. Internal server error. This is not nice. Docker logs workshops. And what we see here is what? A problem. And it says failed to construct component instance. And why that? Connect timeout, client builder. Oh, this is right. And what I do, no such method error. I accidentally used Whitefly 11, which does not support the Java 8 client here. So what we will have to do is, thankfully, we have a bunch of servers here to choose. I will have to switch the workshops to Glassfish. And sorry for that, but this is real life. Exceptions sometimes happen. So just build that. And run it. By the way, if you have just Java 7 application servers, also not a big deal. The only difference is in Java 7, this the connect timeout and read timeout, they are proprietary constant. So we would have to use the Jersey or REST Easy or CXF constants, and not rely on the builder here. Okay, and let's see what happens. And it works, which is good. Docker logs workshops. Workshops. And we see about to invoke public method trainers. So now looks good. So now try to break it. And how to break it in the most effective way, make the trainer service not available. So and how to do that? I can go here and say Docker network. I hope is disconnect. Yes. Workshops, trainers. Now there are no more trainers. Docker logs workshops do the follow thing. So I will see. So, and now switch to here. Try it again. And what you see is the Sicherung is open. So now there are no more errors, and what we see is the null, and the Sicherung is open. There are no exceptions, and what we saw is the unknown host exception trainers. So now there is no way to close the Sicherung right now, but because we do not have any API, so we will have to restart the server. What we do in production, we have a kind of dashboard or a KPI monitoring thing, and with the KPI monitoring thing, we are able to close the Sicherung. What we usually do not do is to use fancy algorithms, because in most enterprise systems, all systems are crucial. And if a backend system is not available, we usually create a ticket, or try to wake up the administrator, and we do try to apply any retry logic. Okay, so we have the communication right now, and let's implement bulkheads. So what bulkheads mean is, we would like first, we can change this a little bit. So what we could do is we could communicate asynchronously here. And how to do that? First, instead of doing this, I can tell here Eric's. So what I would like to use is the reactive way of programming, and say I would like to have a completion stage with type class. with type string. And what I get back is here, completion stage, I hope. Yes, this is my return value. So this is what I get back, and I would like to return that here and say return this. So now my boundary here, workshop workshop resource, calls the trainer store, and the trainers returns the completion, which does not won't look here really nice. So what I would like to do is to change it in complete asynchronous way. How to do that? So I will get rid of this one, and instead of doing this, I would like to make it void and say here, hey, I like to use suspended communication model. Suspended means the server won't block. It will, the thread is going to be parked, so it won't take any resources. And I would like to use the async response. And the async response. What I can do, I can say now the following. So the trainers returns completion stage. So I can say then accept response dot resume. So, and I created my own little pipeline. So what it basically means is I get the completion stage. It's a kind of pipeline, and this completion stage is executed fully asynchronously, regardless how long it takes. And this async response is passed here, and this method will complete, and this thread is going to be parked. And in case the trainers return, we will get the value is going to be passed to here. So it's a reactive programming style. And what I could also do here, I can say, hey, I would like to have a timeout here as well. Set timeout, let's say 2 seconds. This is like to guard, the resource. We probably in more complex applications, it's hard to tell what happens here. So we can say, regardless what happens here, we would like to return to client 503 in case something takes longer than 2 seconds. So, and this could work. So what we could also do, we could create a method add string value at trainers, yeah, and no, at workshops. Or just add whatever will work for us. Workshops catalog dot workshops and plus value. Just do this, return. And what we could do is then apply this add. And then accept. So what happens right now, we get the trainers first, then we add to the trainers, this should be the trainers, we got the workshops, and then accept. Of course, we could use JSON builder and return JSON, but for now, string should be enough. just to demonstrate how it will work with plain Java 8 without any external libraries or frameworks. Okay, we have that. And now let's test that. So, workshops. Remove the workshops first. Then build the workshops. And of course, run the workshops. I even saved that the first time, so which is already a great progress. Run workshops. Hello Duke, looks good. So try to run that. And try, take a look how it looks like. Logs workshops. Oh, workshops. And yeah. So what we get is Docker log curl, or just Docker network inspect workshops. Docker network inspect workshops. And the problem is, of course, we only have the workshops and we have to re-add the trainers, otherwise it won't work. So just do this. Connect trainers. And try it again. And it works. So the problem was I forgot to re-add the trainers. And now we have fully reactive programming style right now. So it is almost robust. Actually, in this particular case, the server will take in cloud a huge amount of memory, at least with Java 8. Why this? Because if we take a look and then apply, then accept, what happens behind the scenes is it will run in fork join pool. So if we go to the trainers and this returns the reactive completion stage, and the problem is the pool is unbounded, or we actually don't know how it's configured, and the completable future usually relies on fork join framework, and this fork join framework usually acquires twice as many threads as we have CPUs, which may cause the application server to acquire several hundred threads. So what we need is a bulkhead. We would like to define the amount of threads consumed here. So we can do this. So we can just set up a executor service, and the executor service can be injected. So we can inject a managed executor service, MES, and we can just pass the managed executor service. So, and the managed executor service can be configured by the application server, and this is actually just an glorified executor service from JDK, and this was introduced with JDK 1.5, so nothing new here. But the cool story is now I can tell the application server, hey, please, this default execution, we don't have to use the default, we could use a named one, but I can configure the managed executor service to have at most, let's say, 5 threads, and in case there are more or less than that, more or less. If there are more, I can specify what happens then, whether the queue should block or not, for instance. So what we have right now, we have 2 patterns. We have bulkheads. This is the bulkhead pattern. And what we also got is the circuit breaker, in German, Sicherung. Okay, so we have a few minutes left. So I will just take a brief look at the questions. So no questions here in Twitters, and also no question in the chat. So now what we can also do, some cutting edge technologies, I can actually create a microprofile application, and let's call it future. Why future? Because Microprofile, Eclipse Microprofile is something like an incubator. It's not a part of Java 8, also not of Jakarta now. But what's the difference? If you take a look, this is a so the 1.2 is implemented by Payara right now. So this is the Microprofile dependency instead of Java 8. So the difference is here in the trainers we had Java 8, and this is Microprofile. And because Payara 4 and Payara 5 supports Microprofile 1.2, I can just deploy to the same server as I had before. But instead of doing this, I can actually implement a health check, for instance, and call it ping health. And this should implements health check. And then I have to return health check response, and I will have to use the qualifier health, and let's do it application scoped. And what happens now, I can just return the health check response and tell the server, hey, I have a health check called future, and it is up, and we can pass some data, health, lean and fast. Does this, and we can create that. So now we have a health check configured, and this should be enough. So I can try to deploy that on my local server on the Payara, because it is Payara 5. It is not in the container right now. So I would like to use the Payara, where is it? Payara 5, and run it. Just run it. And future resources ping. So we have that. And with health, we get the health, which is really nice, because right now we can really easy implement readiness and liveness checks to running on, for instance, on OpenShift. So if I do this -I, you'll see that this is the Payara 5.181 with application JSON, and I get the health check as JSON. So what's also cool is the following. I can get a step further and say what I'm really interested here is in the performance of this thing here, of the ping. So let's say Java is really slow. Let's do this, and what's new Java class, let's call it ping logic. So we have the ping logic and this ping logic compute ping, return hey Joe. And let's say this thing, ping resource, I would like to have this thing there. Ping logic here. So returns hey Joe with that, and so, and this is ping resource. Okay, so now we can inject the ping logic, with logic, and cool, and then of course use it, plus this logic compute ping. And what I can do right now, I would like to say, I would like to count the calls here, count it. And the cool story is, if I would just do this, I get the metric how many parallels calls are going on behind the scenes. But I could say also monitoring true, and now we just count the calls, and And in my ping logic, I would like to have here a timed metric. A timed metric. Okay, so now run it again. And I can now invoke resources and ping. So seems to work. Hey Joe. And the cool story is what we should get is we should get the matrix application. And what we get, just go to the so we see that the boundary ping resource was invoked 4 times, and what we also see is the compute ping rate per second, all the metrics for the invocation of my ping logic, and this is available. This is the strange format is Prometheus format, so it comes out of the box, so you don't have to implement anything. On my YouTube channel, if you like, you can take a look what to do if you don't have a Microprofile available. So I just converted the matrix by the application server from JSON to Prometheus. But the cool story is as well, I could also ask the server to get application JSON matrix. And this they are the same matrix as JSON. And even better, I can skip the application, and then I get the application server metrics like number of processors, thread count, and I get everything here. As you can see, even the application matrix. Okay, this was Microprofile 1.2, and there are even built fault tolerance patterns and configuration, even more powerful what I showed you right now. And what's also interesting is the following. The question is why what I did was so fast. And the answer is because of the project structure. So if you take a look at the Docker images, you will see I have lots of images here. And all the images are suspiciously a half a gig big, which actually this could even blow up my machine because I don't know how many hundred images I have. But if we take a look at the image AirHacks trainers right now, what you can see is the change history, and you can see that the first layer, this is what I presented you with the Java, is 19 months old. This is the CentOS 7 with Java 8. And the what we did 38 minutes ago, we created the trainers image, and this is just 4K. So each deployment to the cloud takes is very fast because what gets pushed is just the 4K, not the full image. And this is where Java EE really shines. What we have the deployment process. So we build the server once, and the server only changes on new release, and we focus on business logic, and we only ship what changes, and this is usually the war. And if we even take a look at the Microprofile future target, you can see even the full Microprofile application with the matrix is also 4K big. So thank you for watching. I hope you saw a little bit how lightweight microservices can be. See you at workshops, upcoming conferences, or if you have questions left, go to AirHacks TV, and this is where I usually stream the stuff. So here you should see, I don't have the Flash player installed right now, but you can ask me questions the first Monday of the month, and yeah, thank you for watching, and enjoy the Java with the Best conference. So thank you and bye.